The next one, part C. In another experiment, equimolar amount. Equimolar means same moles of iron 3 and SCN minus are mixed together and allowed to reach equilibrium. The total volume of the mixture is 25 centimeter cube. We know that 25 centimeter cube is not a standard unit. When we convert it into decimeter cube, it is gonna be 0.025 decimeter cube. Please remember, whenever we are attempting numerical, we must be using the standard unit. Reaction 1 is given. At equilibrium, the mixture contains these molar concentration of these 2 points. Calculate the initial amount in mole of iron 3. That's not given here. To attempt this question, we try to take help from the ice table. Now we have got 3 substances here. We know the mole of iron 3 plus and SCN, they are equal. So we can say they both have a mole at the start when the reaction just starts and equilibrium has not achieved. And mole of FeSCN2, obviously they will be 0 at the start. Now these are moles. Please remember, ice table can only be made on concentrations, not moles. So we must convert this mole into concentration. So in the next step, we are going to write initial concentrations. Look here, mole of iron plus 3 divided by 0.025, that is the decimeter cube, mole per decimeter cube. This is the concentration for iron plus 3. SCN, obviously the same, A over 0.025 mole per decimeter cube concentration. And for this product, obviously the concentration is gonna be 0 because at the start there are 0 mole of FeSCN2 plus. So these are the initial concentrations that comes as I. Now C, we need to calculate the changes in the concentration. As we can see, for this one, iron plus 3, there will be X part removed from the concentration because there is only there is 1 over here, 1 here, and 1 over here. All these have 1 molar ratio, so there will be 1 part of concentration reduced from iron plus 3. The same part will be reduced from SCN, and the same part will be added to this product. Now that is calculation. So that comes to the C part. Now E, the concentration at equilibrium concentration. So what do you think will be the equilibrium concentration of iron plus 3? Obviously A minus X. As we can see, A minus X for iron plus 3, A minus X for SCN, and simple X because 0 plus X is gonna be simple X. So these are the equilibrium concentrations. Now examiner has given us these 2 concentration. SCN minus this concentration is equal to 1.3 into 10 raised to power minus 3. It means A minus X must be equal to this value. Then FeSCN2, this is 0.3 into 10 raised to power minus 3. So this X must be equal to this value. So I have written x is equal to 0.3 into 10 raised to power minus 3, as we can see from here, and a minus x is equal to 1.3 into 10 raised to power minus 3. If we calculate a from here, just substituting the value of x from there, we get a as 1.6 into 10 raised to power minus 3. That is the initial concentration for SCN and for iron. Okay, coming to the next part, that is calculate Kc, the equilibrium constant in terms of concentration for reaction 1, and state its unit. Show your working. So we must show our working as well, because if we don't show our working, we may deduct our some marks. So Kc is equal to the product concentration. As we know, in that case it was 0.3 into 10 raised to power minus 3 divided by the reactant concentrations. And one more thing, because there were 1 moles for product and reaction, so it means there is 1 power for all these numbers. If it had been 2, 3, 4, whatever molar ratio was there, so that particular molar ratio comes as power. But in our case, in reaction 1, all the reactant and product, they had 1 molar relative ratio in balanced chemical equation. So when we manipulate this equation, we get to the point that Kc's numerical value is 177.18. Now coming to unit, mole per decimeter cube divided by mole per decimeter cube square. So we can easily see that the answer will be 1 over mole per decimeter cube. So this can be the unit for Kc. Or alternatively, we can write in this way, like mole inverse into decimeter cube. So 1 over mole per decimeter cube, that becomes mole inverse into decimeter raised to power 3. Thank you very much.